Assalamualaikum warahmatullahi wabarakatuh. So today my group will present for the Green's Theorem. So this group is consisting of 4 members. The group members which is Ahmad Shamsul Ikram bin Ismail, Muhammad Ifan bin Zulkifli, Muhammad Diuddin bin Esa, and Muhammad Abdul Naim bin Muhammad Zifri. So for the introduction, my friend Irfan will present to you.
Okay, our topic is Green Theorem. Now I will tell about the definition of Green Theorem. Let R be a simple connected plane region whose boundary is a simple closed piecewise smooth curve C oriented counterclockwise. If fxy and gxy have continuous first partial derivative and some open set containing R, then integral C fxy dx plus gxy dy equal to double integral R delta G over delta X minus delta F over delta Y dA. Okay, now we move to the question. Use Green's theorem to evaluate this equation where C is the triangle with vertices 0, 0, 1, 0 and 1, 2 with positive orientation. First of all, we do the graph. This is the graph with positive orientation. Next. Now we move to the solution. Integral xy dx plus x square y cube dy equal to double integral. This is the general equation. So we find the equation of OA over here and we get y equal to 2x. Next, we find f and g. Based on the equation, we get delta f over delta y and delta g over delta x. Next, based on the general equation, we get the equation here with the lower limit y over 2 to 1 and for lower limit y 0 to 2. So down here, I put out the x. Next, I integrate the x. I get x squared over 2 with limit y over 2 to 1. So I substitute the value and I got y minus y squared over 4. Next. So I put out the 1 over 2 out the integral. And I integrate the equation. So we get over here with the lower limit 0 and upper limit 2. So we substitute the value and we get over here 2 minus 2 equal to 0. That's all from me. Now my friend will continue with his question.
Okay, thank you, Irfan. My question is integrate C y cube dx minus s cube dy, where C is the positively oriented circle of radius 2 centered at the origin. Next. So we got our circle which have radius of 2 and the counterclockwise direction. Next. For the solution, we find our f and g value from the question. For f, we got y cube and g, we have negative x cube. We differentiate f respect to y, we got 3y squared. We differentiate g respect to x, we got negative 3x squared. Okay, next we substitute the value of df and df over dy and dg over ds into our general Green's theorem. Okay, next we factorize. We take out the 3 and we got negative x squared minus y squared, which is equal to negative r squared. Okay, so we substitute dA into r dr d theta and solve it using polar coordinate. Okay, for r limit we got from the circle, we which is from 0 to 2. And for theta limits, we got 0 to 2 pi. Okay, so we integrate the arc. We got 1 over 4 r power of 4 from limit 0 to 2. So with the negative 3 we take out because it is a constant value. Okay, so from we integrate we got 4. So next we integrate d theta we got 2 pi. So we multiply negative 12 to 2 pi and we got the final answer is negative 24 pi. Okay, that's all for me. So Ramiro Naim will continue with the next question. Thank you.
So thank you, Isham. So for my question, uh, we have to. So the question is integral C. Sec 1 plus x cubed x plus 2xy dy, where C is the triangle with vertices 0, 0, 1, 0, and 1, 3, with positively oriented. So we plot a graph and we got this positively oriented triangle. So that is the region. And next, so there is a general equation with the vertices of triangle that I've stated. So using Green's theorem, um, we will have a double integrate r with the limit r to y minus 0 dA. So the first one we will find f, the value of f and g. So f is we solve for the sec 1 plus x cube. And g we solve for 2xy. We got delta g over delta x is 2y and delta f over delta y is 0. So after that we substitute into the equation, and so dA we will be dy dx. So we will solve 2y and we will got y squared with the limit 0 to 3x dx, and we will solve for the dx. We got 3x cubed, we x squared dx, and after that we will get 9x squared dx, and we will solve again for the dx, and lastly we will got 3x cubed with the limit 0 to 1. So we solve that and we got 3 as the final answer. So after I will Din will present.
Okay, thank you, Amrulai. So my question is integral y plus exponent set x dx plus 2x plus cos y square dy, where C is the boundary of the region enclosed by the parabola y equal to x square and x equal to y square. So if we plot the graph, so this is my y equal to x square graph, and this is my x equal to y square graph. So the region enclosed by these two parabola is this region. Okay, so we must find our f and g first. My f from the question is y plus exponent set x, and g is equal to 2x plus cos y square. So we find del f over del y is equal to 1, and del g over del x is equal to 2. So we substitute the value into the general formula, and we got 2 minus 1, and for my dA is dy dx. My y limit is from x square to set x, and my x limit is from 0 to 1. Integral dy, so we get y, and substitute the value x square and set x, and then we get integrate 0 to 1 set x minus x squared dx, and then we get 2 over 3 x to the power of 3 over 2 minus 1 over 3 x cubed, and substitute the value 0 to 1, and we get 2 over 3 minus 1 over 3 And the final answer is 1/3. That's all from us. Thank you.